Okay, yeah, we've looked at our shift register so far, the shift left and the shift right, and we've explained the technicalities there. Now what I want to look at is, let's look at what I'll call the OR circuit, the selector circuit. All right, let's say it's an OR circuit, so it's one or the other. All right, so this is our output. So we can go one way or the other. All right, so I can decide. But then now, if I want to have, let's say I want to put a 1 from this side, or I want to put a 1 from the other side. The tricky part here is, if I don't have a control, a way of controlling, then we won't know what's happening. We won't know whether the 1 is coming from that side or from that. What do we do then? We improve this circuit and say, okay, let's be able to select. So how do I select? I use my AND gate. Okay, I use my AND gate. Alright, with my AND gate now, I can say I have this information from the left, this is the left, and I've got that information from the right. Alright, so now I can say with a control, not happy, I'm not happy, so what I'll do is go back a little bit and say this looks a little bit too long. Okay, there's my inverter, and I say okay. Right, with the 1 here, let's say I start with a 0 here, that 0 is seen at this gate here, and that 0 is converted to a 1 there. What does an AND gate do? The moment it sees a 1, I want to say an AND gate, the moment it sees a 0, that 0 goes through, so it ignores the other side. So what I'm doing here is, if this was my my right shift info, it's from the left going to the right, my right shift info is therefore blocked with a 0, but that one there says I want to know what you are. If this is a 0, the 0 goes through. If this is a 1, 1 and 1 is a 1, the 1 goes through. So this one is open, so the 1 opens this gate so that the left shift information can go. So what is this here? This is basically a select switch. We are going to meet it in a lot of applications where we are either going to say one or the other, shift left or shift right. There's going to be a lot of other applications where this is going to come in handy, but I want people to understand this selector circuit first. And I'll take my selector circuit pure. Hopefully people understand it now. I'll take my selector circuit pure and say, since we know this is going to say left or right, it can do left or right. It's a selector generally, but it can do also left or right, obviously. So what I'm going to do is I'm going to take my circuit, and for the time being I'm going to place it here. All right, what I'm then going to do, and I'm going to say, okay, I want a shift register, so I know it's supposed to use D or whatever else configured as a D. So I am going to, on purpose, use JKs. Why? I want us to deal with an example that will have a D, something else other than what a JK. We made an example. We showed you what we can do with an SR or a what, or a JK. We're gonna go with JK. So I said it's best practice to use JKs all the time, even though mixing won't really create major faults unless there's other parameter differences. All right, so now this is JK, so we have to, I'm going to use the trailing edge one, the master slave one, trailing edge one, the master slave one. I'm not trying to be, my symbols are not as perfect as they should be. It's a little arrowhead there. They're not as perfect as they should be because it's not difficult to use this instrument I'm using. Okay, now remember that it's supposed to be configured as a what? As a D type. So the Q's and not Q's are not redundant. Now, shift registers work synchronously. Otherwise, the what call this? The flip-flops won't open at the same time, so it has to be synchronized so that they open at the same time. So that data is allowed to glide through. So that the bits can follow each other. Alright. So it must open synchronously. So now this is a clock. Obviously with this one here is going to be responding to the trailing edge. Now, the first one being a D must be configured as a what? Being a JK, sorry, must be configured as a D. And we know that is what? That will require that inverter between the two inputs. Alright. So, what I'm going to do here is I'm going to want to what? I'm going to want to shift left or right. So, the inputs here, the Q's are not affected. The Q's are the Q's. This is Q2. This is Q1. This is Q4. And that's Q8. That's Q8. Alright. So now I need my input to come in. This one here can, when you are going to the what? When you are going towards the what? The left, our input is going to feed it, or if you are going to the right, that guy is going to feed it. So I need a what? A selector circuit here for what? For him. So what I'll do is I will comment take 1 second and say you will, what am I doing? It's confusing. Oh, because this thing is here. Alright, this thing has this problem. What I'll do is, okay, Control Z. Let me move it out for the time being. Let me move my circuit. This guy has a boundary, an invisible boundary here. So I'll bring it somewhere here. Now say I need him. No. I'm gonna need one here to say we are fitting. Oh God, we are fitting. It's gonna be too big. It's too big. Okay, let me undo this. It's a little bit big. Too big for my application. What I'll do is reduce the size and bring it hopefully here. Okay. Okay, I'll just put one there. Alright, what I'll do is I'll just put it there because it's really making me struggle. I'll put another one there for this one. Put another one there for that one. And one last one is, because each of the four is going to be fed by one or the other. So I'm going to put one for each. This one is going to be fed by either the input to the what? To the right, or the what? Q4 going to the left. Okay, same here. This one's going to be fed by Q8 or Q2. That one there, that one's going to be fed by Q4 or Q1. That one there is going to be fed by input or Q2. So we need four of them. Now what I can then do is, let me try to reduce this a little bit more. Why? I think it's a little bit big. Alright. What I'll then do is I will, no, I need to ungroup first. Ungroup them. Ungroup. Ungroup. And ungroup. Now, so we know that this one here, the first one, I need to put them a little bit, but this one is refusing to go to the side. So what I'll do is this one here needs to fit the first one, is the input to the first one. It would have been nice if it was nice and straight. Nope. Okay, that one there fed by its own, that one there by its own, that one by the first one. It's a little bit tough. Now, what we then need to remember, oh, we forgot that we need to what? To have a certain reset there. I'll have a reset. Then we know that this here is the input series in series for the what? Input for the what? For the left shift. Okay, that one there is the series input for obviously the right shift. Okay, all right. So what then happens is the control here, the control must be common, so we wire all these here together. Okay, and when you say 0, 0 blocks this, the what? The input to the what? To the right. It blocks the ones that are going to the what? The right side. So what you call this? It allows the what? The left shift. So this is how we shift left, by putting a 0. Left shift. But when you have a 1, it's what? It opens the right shift and it blocks the left shift. So the 1 is the right shift. Okay, so what I didn't mention here was with a 0, okay, that one is blocked. I didn't mention that. That one there is open, so the left shift is open. But with a 1, the 1 opens the what? The right shift, and it becomes a 0 here and blocks the left shift. It becomes a 0 there and blocks the left shift. Okay, so the 0 here will be left shift, 1 will be right shift. Okay, now so what we say here. So what you then do is the input comes in, comes out there. That input there must come, that output, sorry, must either be the series out. Okay, this could be the series out, for the left shift. Okay, and this here could be alright. I'll come to that. It's a series out for the what? For the right shift. But I'll come to that because I want to have lines that are going to cross what I'm going to write. So I'll do that later. So this here, when it comes to the right, it comes to the next one. If we are going right, it's going to come and feed that one there. Okay, that comes out, it comes and feeds that one there. That one comes out, it comes and feeds that one there. So if you are going right, which we place a 1 there, The one opens these gates 1, 2, 1, 3, 5, and 7, and it blocks that 2, 4, 6, and 8. So then our input comes in, it goes out, goes to the next one, comes out, goes to the next one, comes out, and goes to the last one. All right. But we could have been going right, if in which case, if we are going, sorry, we could have been going left, in which case that there comes out and feeds the next one. Okay, that there comes out. I'm gonna have traffic, so I'm gonna do that because we're gonna be the same line here, feeds the next one. That there comes out and feeds the next one, and then our output comes out. So this here now I can safely say that there is our Q1 is our series out for the right shift. Okay, this is supposed to be a circuit. So all I wanted to introduce here was the OR circuit and show you how we can actually design a shift left or shift right. I think the benefit of having a video is to slow down, to repeat, is to do whatever. You can play this over so many times until you understand what's going on, if the first time didn't work. Again, remember that this, if we chose to, this will still be our parallel output. And we would need 1, 2, 3, 4 clock pulses to get our parallel output. But if we're going to get our series output, we need one less more to get the series output. What do I mean? One less more. Look, if we need 4 clock pulses, we need one less more. One less is 3 more. We need 3 more to what? Remember, we need n for the number of number of bits are 4, so in this case it's 4, and then we need 1 less n minus 1 to get a serial output. Okay, so we need the sum of these two. We need 4 to get a parallel output. We need 1 less more, meaning you add 3. You need, if for a 4-bit you need what? 4 clock pulses. For a what? For a parallel output. But for a serial output you need 7, because you need what? 4 plus 1 less, which is 4 plus 3, which will be 7 clock pulses to get a serial output. Okay, so I think this was well, I hope the circuit putting it down made things a little bit clearer. And then next phase, what I will look at, what I want to look at what other very okay parallel in. How do you have a parallel input in? How do you have a what call this parallel in? How do you control the output? What call this? Look, let's suppose these queues were supposed to run certain gadgets. While the data was coming through, there could be fake drives here. Whatever this is was supposed to be driven here, before we feed our output, though, as long as this becomes hot, it could drive something. That could, so we don't want that one. When you are done, we want to ultimately say, now you can you can come out. So we're gonna add a little bit here to say a control here to say, okay, now want out. Obviously you can see what it is. Our control is going to be what? It's going to be very simple, but let's cross that bridge when you get to it. For now, I don't want this video to be too long. The part I wanted to explain here was shift left or shift right. Ciao.